This is a short module on the concept. Visit mockat.com to access the complete concept video, practice questions, quiz of the day, and other free resources to start your prep right away.
Now we should look at the last two digits of numbers, which are exponents, right? So once again, we will use t of something, right? So if it's going to be 3456 to the power of 478, I'm concerned only with the last two digits, right? So that's the t of function. So 34 I'm not going to be bothered about. It's just going to be the last two digits of 56 to the power of 478. Now to the first part. Now where the last digit of x is going to be 5, right? So the following rules apply. Let's go through it. Where n is greater than 1, the last digit of x is 5 and 10th digit of x is even. Then the last two digits of x power n is 25. Once again, in x power n, x is the base, n is the power. If the power is going to be more than 1, right? And what's the condition for x? The last digit is 5 and the 10th digit is even. So if you're going to have something like 4325, right? To the power of anything, right? So anything over here, the last two digits will be 25 as long as this n is greater than 1, right? So the conditions are fulfilled because the tens place is even and we have 5 here. So if you're going to have 147, yeah, so the last two digits over here is going to be 25. The last two digits of, let's say, 5605 to the power of 17, right? So once again, that's going to be 25 because the tens place has an even number there. Now, what if your tens place is going to become odd, right? So let's say 5615 to the power of 74, right? So what happens over here? If the tens digit of x is odd, right? So then the following two, it's going to be broken down into these two. The last two digits of x power n is 25, where the power is even. The power over here is even, right? So therefore, my last two digits are 25. Now the second case, the last two digits are 75, where n is odd. The power is going to be odd. So the last two digits of, let's say, 5675 to the power of 63, right? It's an odd power. Then it's going to be 75 over here. It's either going to be 25 or 75, always the last two digits. If the tens place is going to have an even number, it's always 25. If the tens place is going to be odd, then I have to check if the power is even or odd. If the power is even, then it remains 25. If the power is odd, then it becomes 75. Once again, the tens place is odd and the power is also odd. If both end up happening, then it's 75. For all other cases, it's 25. So let's take a couple of them. All right, so t of 85 to the power of 567. Right, one of them is even. Tens place is even over here, so it's 25. So what is 4335 to the power of 33? Tens place is odd, power is also odd, so it becomes 75, right? So all other cases, if you're going to have 4605, it's an even tens place, it doesn't matter what the power is going to be, right? So it will end up becoming 25. Now, if this is going to be, let's say 4695, this is the tens place is odd, and the power over here is even, all right? If it's even, then you end up with 25 once again, right? You get 75 only if the tens place is odd and the power is also odd. So now if the last digit is going to be 5, you should be able to find the last two digits at ease. Now if your last digit is going to be 0, it's very, very easy, right? So let's say 50 to the power of, let's say 37. What are your last two digits going to be? It's going to be 0 and 0 because your last 37 digits in fact are going to be 0, right? You have a 0 here and to the power of 37, you're going to have so many zeros towards the end that your last two digits will be 0 and 0. So when will it not be the case? If your power is going to be equal to 1, right? So if it's 50 to the power of 1, then your last two digits are 50 itself, right? If it's going to be more than 1, if it becomes 2 or 3 or more, your last two digits will be a 0 and a 0. Now even numbers are going to be broken down into two parts, right? So one where x is a multiple of 2 but not 4, okay? The other is where it's a multiple of 4, we'll see soon, right? So let's start with this, where your number, right? So your number x over here, the base, is a multiple of 2 but not 4. So it's going to be something like 6, right? Or 10, right? 10 is a multiple of 2 but not 4, 14, 18, and so on. Now what this says over here is, right, so take one such number, 574 let us say, right, My last two digits 74 over here is not divisible by 4, but it's an even number, to the power of 41, right? So anything in the 40k plus 1 format, right? My last two digits will end up becoming x plus 50, 74, right? Which is the last two digits over here, plus 50. 74 plus 50 becomes 124. So my last two digits are going to be 24. So the power over here has to be in the 40k plus 1 format. So it's going to be a little difficult to operate with, right? So what are the other 40k plus 1 formats? 40 into 3 plus 1, 121, or 40 into 2 plus 1, 81, 121, right? 161, 201, and so on. So if you get something like the last two digits of 574 to the power of 82, the way you need to do it is you have to break it down into two parts, right? So first up, we can ignore 5 over here, right? So it's going to be 74 to the power of, right? So to the power of 81 into the 74 power 1 over here, right? So the last two digits over here for 74 power 81, we know that's going to be 74 plus 50, which is 24. Now once again, why is that so? 74 over here is a multiple of 2 but not 4. Second, the power over here, which is 81, is in the 40k plus 1 format, right? It's 40 into 2 plus 1. So therefore, the last two digits will be the same as the last two digits of x plus 50, right? 74 plus 50, it's 124. The same last two digits over here, okay? And last two digits of 74 remains as 74. Now, these two you need to multiply, all right? So what did we do? 74 and 24, 4 fours are 16. We just discussed this. Cross multiply and add. 28 plus 8, that comes to 36, plus 1, that's 37. 3 carry up, we don't need that, we can just stop at this and say 76 is going to be the last two digits here. Let's take up an example over here. What are the last two digits of 86 to the power of 283, right? We just discussed this. 283 over here is very close to 281, right? 281 is in the 40 into 7 plus 1 format, right? 40k plus 1 format. So we can write this as 86 power 281 into 86 square, right? So the last two digits of 86 power 281, right? So that's going to be, this 281 is in the 40k plus 1 format. So it's going to be the last two digits of 86 plus 50. That comes to 136. So 36 become the last two digits for this into 86 square, right? So what's 86 square? 86 into 86. 6 6 are 36, 3 carry up, 48 plus 48 is 96, and I get 99. So this is going to be 96, right? Once again, the carry up and all I'm not bothered about. It's just the last two digits which I want here. Now 36 into 96, once again, I'll look to find the last two digits. 6 6 are 36, 6 into 3, 18, plus 54, that's 72, plus 3, which is 75, right? Again, I don't care about that. It's 56 over here, which is going to be the last two digits. Once again, your focus should be only on the last two digits and nothing else. The next is where x ends up becoming a multiple of 4, right? Where x is a multiple of 4, then x power 40k plus 1, right? So let's take a multiple of 4, let's say 48, to the power of a 40k plus 1, let's say 321, 40 into 8 plus 1. The last two digits over here is going to be that of x itself, which is 48 itself. In the previous case, where it was not a multiple of 4, but a multiple of 2, I had to add 50. In this case, I simply don't need to. I write it as it is. Let's take up example 19. This is again a slightly difficult problem, right? So a question like this is unlikely in the exam, but it's good for practice, right? So it will help you. Right, so this is a multiple of 4. The power has to be brought to the 40k plus 1 format, right? So 40 into 50 is 2000 plus 1 gives me 2001. 2001 is in the 40k plus 1 format. So I can write this as d of 2016. In fact, I shouldn't even be writing 20 over here, right? We can get rid of that. 16 to the power of 2001 into 16 to the power of the remaining 15, right? The remaining 15, I can't do anything. I just keep it as it is. Okay, so what's going to be the last two digits of 16 to the power of 2001? This is a multiple of 4. So it's going to remain the same last two digits, right? So it's going to be 16 itself into 16 power 15. And what do we get here? It's 16 power 16 now. So I need to find the last two digits of 16 power 16. There's no easy way of doing it, right? So there are no other techniques which I've told you. So we have to do it the plain simple way of just multiplying them. Let's start with 16 square, right? So 16 square over here is 256. If you know the powers, it will be helpful. Number theory lesson, we've discussed it. So here we're going to get 56, right? The last two digits. Now T of 16 power 4 over here, right? It's going to be 16 square into 16 square. That's going to be 56 into 56, the last two digits of that, right? So 56 into 56 is going to be 6 6 or 36, 3 carry up, 30 plus 30, that's 60, 60 plus 3 is 63, 36. That's all I want. Now, for 16 power 8 is going to be 16 power 4 into 16 power 4, right? So that's going to be the previous one, 36 into 36, right? So what do we get here for 36 into 36? 6 6 are 36 and 3 carry up, 18 plus 18, 36 plus 3 is 39, so 96. 96 over here. Last step is to 16 power 16. That is nothing but 16 power 8 into 16 power 8. So that's going to be 96, which was for 16 power 8 into 96, right? So what's 96 into 96? 6 6 are 36, 3 carry up, 54 plus 54 is 108. 108 plus 3 is going to give me 1. That's the last digit right there. So 16 is what we get, and that's the answer for this question. Now to the last part. What if the last digit of x is an odd number other than 5, right? So before we get to that, let's understand this. If the last digit is going to be 1, right, it's going to be very, very beneficial. Let's say we have 561 to the power of, let's say, 87, and we need to find the last two digits over here. The thing is very simple, right? So the way it works is this. The last digit we know is going to be 1 for sure, right? The tens place over here, right? The tens place over here is going to be the product of the units digit in the power and the tens digit in the base, right? 6 into 7, we get 42. But I can't write 42. I just need 2 over there, which is the last digit of that, right? So once again, let's take up one more. Let us say we have 381, right, to the power of 46, right? So what's going to be my last two digits? Here my units digit is 1, which is good. So units digit becomes 1. Now for my tens digit over here, it's going to be the product of the tens digit in the base with the units digit in the power. 1 we made use of, go for the next digit into the first digit available over here from the right. So 8 into 6 is 48. So I don't need to write 48, it's just 8 I'm going to write, right? Of the 48, it's not the 4, it's just the 8 I'm concerned with, because I just need to fill my tens place up over here. So let's take up one more over here. T of, let's say, 371 to the power of 63. So what's that going to be? My last digit is going to be 1, right, as we discussed. The previous one, the tens place is going to be 7 into 3, which is 21. So it's a 1 again. In 21, my last digit is 1. So the answer is 11 over here. 1 and 1 are going to be the last two digits over here. Now, if my last digit is an odd number other than 5, what can they be? 1, 3, 7 or 9, right? Now, if the last digit is going to be 1, then we know how to do it. I've just shown it to you over here. So this we know. Now, if it's going to be 3, 7 or 9, there's no direct rule or there's no direct method. What we need to do is, we know that all of these, when raised to a certain power, will result in a units digit of 1. What is that going to be? 3 power 4 over here is 81. 7 power 4 would give us 2401, brings to 1. And 9 square over here would bring to 81. The units digit would become 1. So if a number is going to end with 3, 7 or 9, you need to raise them to these powers over here, such that the units digit is brought to 1. Then you apply this rule. So once again, the concept is this. Raise x to a power such that the units digit becomes 1. The units digit of the resulting number raised to any power will always be 1. We saw that. The tens digit of this number, right? So one last time, let's do it, right? So let's say 3,431, let us say, to the power of 288, right? What's that going to be? The last digit is going to be 1 always. The tens digit of this number is the product of the tens digit of the base, which is 3, and the units digit of the power, which is 8, right? If this is a 2-digit number, then just take the units digit. 3 into 8 is 24. It's a 2-digit number. I'm just going to take 4 over here. 41 are the last 2 digits here. On to example 20. What are the last 2 digits of 637 part 92? It's just the last 2 I want. So I'm going to look at it as 37 to the power of 92, right? Now 7 to the power of 4 is going to bring it to 1 as my last digit, right? So I need to make it as 37 power 4 and something. So what is it going to be? It's going to be 37 to the power of 4. Whole power what will give me 37 power 92. Whatever I'm going to put over here, I'm going to multiply these two powers, right? So 4 into what is 92? 92 by 4 gives me 23 over here, right? So 37 to the power of 4. Whole power 23 is 37 power 92. Now 37 to the power of 4, right? I need to find the last 2 digits of that. Now how do I do that? Now the last 2 digits of 37 square, we'll start with that. 7 into 7 is 49, 4 carry up. 7 3s are 21, 21 plus 21 is 42, plus 4 is 46. So I get 69 here. Now these are the last 2 digits of 37 square. Now for 37 power 4, I'll have to multiply the 69 twice, right? So 37 square into 37 square is 37 power 4. So let's look at the last 2 digits for this. 9 into 9 is 81, 8 carry up. 9 6 are 54, and same here, 54 plus 54 is 108. 108 plus 8 is 116. So 6 and 11 carry up, but I don't care about that. 61 are the last 2 digits of 37 to the power of 4, right? Which I can write over here, and I get 37 power 4 I'll replace with 61 now, and to the power of 23, which continues. Now it's easy for me. I have 1 over here in the units place, right? The last 2 digits, the units digit over here of the last 2 digits will remain as 1. The tens place over here is going to be the tens of the base into the units of the power, with 6 3s are 18, and I will take 8 from that, right? So 81 is the answer for this question.
If you found this video useful, please like and share it. Subscribe to the channel and let us know what you'd like to watch next in the comments below. Don't forget to visit Mockat.com to access free resources to get through your Dream B School.